Right, so a helicopter flies on a bearing of 200 degrees from A to B, where AB equals 70 kilometers. So using this diagram, it's from A to B. This is where you get the 70 kilometers from. Now, bearings is always from due north. So this would be, this whole thing here is 200 degrees. This is a straight line, so that makes that 180. So this explains where the 20 degrees come from. So this really helps you out with this question. Now it then flies a bearing of 150 degrees from B to C. So remember, 150 from due north would be something like this. So that's 150, that is the bearing, and that's where you'll come unstuck with this type of question if you're unfamiliar with bearings. So this is where this 30 degrees come in. We know that must be 30 here. Now this is where you have to apply your problem solving skills. That's why this is a P in it, and if you can do these types of questions, it will really help you get a good grade in A level. So if I highlight these lines, you should know that if they're both going north, they're parallel lines. And if we can remember that, I hope you can see this thicker yellow. Can you see the upside sideways Z? And we know this is 20, hence this angle is 20. Again, in a different colour, that you see the Z angle there, the alternate angle. We know this is 30 because of this 150 in a straight line, so this must be 30. Now once we've got this information and can work this out, this question becomes a lot more straightforward, because that's why we know now that this angle here, B, is 130, and from there we should be able to do this question quite easily. So using the sine rule, so we're going to use B over sine B. So B's here, because they want us to find the distance from A to C, and this is quite nice because they've labelled the triangle ABC. So we know that equals, we have to use C here because you've got the opposite length of 70. C over sine C. So we substitute those values in. So B is essentially AC, and obviously we multiply by sine B on both sides to isolate or make B the subject. So C times sine B all over sine C, and that will get us our answer. So all you need to do, ensure you do this in an exam question for your method marks. And we said B is 130 over sine C, which is 30. And a key point, always get into the habit of doing final answers to 3 significant figures, because most exam questions ask for answers to that type, but do not over round too early. And that's quite easily done once you've got the grips of bearings and can recognise the alternate angles or the corresponding angles or the co-interior angles. So question 5, you have 2 radar stations, A and B, and are 16 kilometres apart. So this is this bit here. This is when your bearing knowledge comes through. A ship is known to be on a bearing of 150 degrees from A and 10 kilometres from B. So this is, you have to break down this question because you know it's 150 degrees from A, so it's got to be somewhere along this line further down. Now, but it's 10 kilometers from B. Now 10 won't go here, so we're just estimating it. So this could be a possible place. That's why they named it C1 and C2. So you should be able to see that's 2 possible shapes, and if you remember, that's why there is no as incongruent triangles, if you remember that from GCSE, because the sides here, you can have two different sides which will change the triangle, and the side lengths are the same. So if you use a sine rule, you've got sine c over little c, which is 16 in this case, equals sine a over a. So we have sine c over 16, this side here, opposite the angle C, equals sine 30 over 10, because we've got the 30 and the 10. The 10 is opposite the angle. So we should get sine C to equal 0.8. Now, if you inverse the sine of this answer, you should get 53.1 degrees. Now, if you remember the sine graph, it repeats and its period is 360. You need to remember that 180 minus, say, x will still equal the same answer. So the other angle could also be 180 minus 53.1, which is 126.9 degrees. That has to be an isosceles triangle, because they're both two sides are 10 kilometers. So you could just use the Cos Rule. So let's just draw this triangle here. So if this looks like that's the obtuse angle. So that's the 126.9. So here, this side must be, because it's a straight line, 53.1. So we're going to say that's 53.1. We've got a right angle here. That's 10. So if you do cos 53.1 equals, that's h and that's a over h, we get 10 cos 53.1, which equals 6.004, and then that's half the base of that isosceles. So we just times that answer by 2 to get 12.008 kilometers, and if we were to round that to three significant figures, that will just be 12.0 kilometers, and that question is complete.